This video shows how to find a matrix representations for a series of linear transformations of a vector in R2. So if we look at these vectors here, it has its initial point at 1, 0 and its terminal points at 2, 1. So I created a matrix that is representations for these vectors using 1, 0 as its first column and 2, 1 as its second column. So if I want to share this vector by a factor of 2 in the x directions, A is the matrix representation for these linear transformations. And you can see that 1, 2 here will help us share these vectors by a factor of 2 in the x directions. And if you multiply A to V, you get a new matrix, which is a new vector. And as you can see that the red is the initial vectors and the blue one is the new vectors. And you can see that the blue vectors has the same x coordinate, but the y coordinate is sharing to the right, paralleling to the x-axis, and is sharing by the factors of 2. Now, if you want to reflect this vector over the line y equals x, then you can use this matrix as a matrix representation for these linear transformations. Because if you want to reflect a vector over the y equals x, that means you interchange the x and y coordinates. So that's why in order to come up with this matrix, you just need to take an identity matrix, 2 by 2 identity matrix, and you swap the 2 rows or the 2 columns to come up with this matrix. And you take this matrix, multiply to the vectors v to get a new vector. As you can see here, the red vector is the initial one. Y equals x is this yellow line. And the purple vectors is a new one, that is a reflections of this red vectors over the y equals x line. The third matrix representation is a presentation for the expansions of a vectors by a factor of 2 in the y directions. So if you want to do this linear transformation, you just first take the identity matrix and then replace 2 by the 1 in the identity matrix here. The reason is if you use this 2 here, you will expand the y coordinate of the vectors by 2 in the y directions. Okay. So then if you multiply this matrix C to V, you get a new matrix, which is a new vectors again. And this is the initial one. And the blue one is a new vectors after you expand these vectors by the factors of 2 in the y direction. All right. The last one of matrix representations of linear transformation is rotations. So if you want to rotate a vector counterclockwise by 90 degrees, for example, then you can use this matrix representations as the rotation matrix. And since you want to rotate it by 90 degrees, you just need to replace 90 degrees into theta, evaluate it to get this matrix here. And you take this matrix, multiply to the V matrix to get your new vector. And your new vectors, purple here, is the vectors that is formed using this red vectors and rotated 90 degree counterclockwise. The next step is, once you have the 4 transformations, how can you combine those 4 transformations into just one 2 by 2 matrix? Let me remind you, first we share the vector by factors of 2 in the x directions. Second, we reflect the vector over the line y equals x. And then you take the new vectors, you expand it by the factor of 2 in the y directions, and lastly you rotate the newest matrix or counterclockwise by 90 degrees. So here, the first matrix representation, the shear matrix representations, is this matrix. And then if you want to apply the newest matrix onto this linear transformation, you want to reflect a vector over the line y equals x, you take the matrix representations of the reflections multiplied to the matrix representations of the shearing to the left. Okay, and you keep doing that if you want to keep adding linear transformations onto a matrix. And then the last one is the rotation matrix is multiplied to the left of this matrix. You multiply all this together, you get a matrix that is the representations for 4 different linear transformations in order, right? Shearing, reflect, expand, and then rotate. Then if you multiply this matrix to V, you get a new matrix, which is a matrix that is a representation for the new vectors after applying those 4 linear transformations onto this red vector.